sometimes scenarios are kind of tricky because they're simple. This sawtooth diagram scenario is a good example of that strange effect. Let me show you what I mean. Consider the sawtooth diagram below, which illustrates the inventory issues associated with SKU 0012, a small stamped metal part produced by the Can-Am company over the last 40 days. Right, sawtooth diagrams are inventory levels over time, so we're looking at 40 days worth of inventory levels for SKU 12, basically. Answer the following questions based on this diagram. Now, first off, it says, what is the maximum inventory level for this SKU 0012. Now, you're probably thinking, and this would be good, oh, I am looking at the sawtooth diagram, and that looks like an EPQ problem, right? Economic production quantity, because I see that there's definitely a production and consumption phase where inventory is climbing over time, and then it falls, and then it's climbing, and then it falls. And then this question is asking, what's the maximum inventory? And okay, for the EPQ model, that's a formula, because what you want to do is say Q times P minus D over P, and that gets you maximum inventory. But then you're thinking, how am I supposed to find out? This is the production rate, the daily demand, the actual quantity. Where is that? That information's not given. Now, that information's not given because actually you don't need that formula. That is the formula for maximum inventory that would be appropriate for the EPQ model, which is exactly what we're looking at here. But speaking of looking, maximum inventory is right here. It's the peak of the teeth. Where are they topping out at? 60. Oh, I could just read it. 60 parts. Maximum inventory. Done. Okay. How long can Can-Am company operate on a single order of SKU 0012? And think, oh, we have to figure out the order cycle length, and that's like Q divided by D. Now, whoa, wait a minute. Do we actually need that? How long can they operate on a single order? The order cycle is the length of the base of any one of the teeth. Well, if I just looked, how long is the length? These are identical. How long is the length of the base? 9 days, 10 days, 11 days. They're always ending at 12 days, 24 days, 36 days. That's the answer. 12 days. The length of the base of a tooth in a sawtooth diagram is telling you the length of the order cycle. The order cycle is how long an order lasts a company before they start again on a new order. Okay, so it's answered. You can just read it. Let's see what else we can. What is the runtime on a single order? Okay, runtime, that's Q divided by P. Well, wait. Do we need to know Q or P? Because runtime is apparent just as the length of the base of a tooth is the length of the entire order cycle, and that's 12 days long. We just confirmed that. From here to here is the runtime. Because the runtime is how long it takes you to produce an order, and you can see that on this graph because while they are producing an order, the inventory is climbing because they're working. And so it's just, okay, how much time passes from here to here? Because here's where they shut off the machine and just coast off of inventory. Then, you can look at this and see it on the number line, but you can also just look at the actual teeth. And how you go, oh, those are isosceles triangles. They're symmetrical. They're the same on each side, which means that peak is cutting the order cycle exactly in half. Yeah, the runtime must be 6 days because it's 6 days of runtime and then 6 days of just consumption and then 6 days of runtime and then 6 days of coasting on that, just consumption, 6 days. Okay, next question. If demand for SKU 0012 is 10 parts a day, okay, if demand is 10 parts a day, we're actually being given some data. Lowercase d for daily demand, 10 parts a day. Fine. What they want to know, what order size is Con-Am apparently using? Now, again, you may be thinking, formulas. Okay, the Epq formula is the square root of 2 times d times s divided by h, and then wait a minute, times the square root of, what is it, like p over p minus d. Well, there's a actually much simpler way to determine, in this case, what the answer is. That is the formula that would be appropriate to this particular situation, but it's like so many other things we don't know, like the s and the h. One thing we do know, though, we answered this question over here, B. We said, okay, the order cycle is 12 days. You can see that on the graph. That means an order lasts the company 12 days. Well, if the company needs this part at a rate of 10 a day, that's what they just said. 10 times 12 equals 120. That has to be Q. That is apparently the order size. Because if they need this or using this, it's being demanded at a rate of 10 a day, then an order for 120 would last you 12 days. And that's exactly what we are observing on the graph. Perfect. Answered. Last question. If demand for SKU is 10 parts per day, yes, we knew that. I'll write it again. At what rate is Con-Am apparently producing these parts? It's asking for P. Well, we could use our knowledge of formulas to answer this. I mean, we wouldn't be wrong, because going back to the first question, I did jot this fact down. This is maximum inventory, right? And we know it's 60. Notice by the time we get to this question, we know a lot more stuff. We actually know what Q is. We know that's 120. It's asking for P, but we know what D is. And if I piece all that together, the only thing I need to do is solve for P, right? So it's like 120P minus 1200 equals, was it 60P? I was just multiplying through there, which I'll solve for P. What's P wind up being? 60P equals 1200. P equals 20. Yeah, that's actually the answer. And I did finally use one of the official Epq formulas. Okay, that apparently the production rate is 20 a day. Although I didn't really need to. There was a faster way to do it. That wasn't wrong. Okay, but there was a faster way to do it based on the other things that we learned from the other questions. We learned from the question before it that the order size is 120, that they're making these 120 at a time, okay? And we learned from the question before that the run time is 6 days. So it takes them 6 days to make 120. I could have skipped all this if I just said, okay, fine, 120, that's Q. Divided by 6 days, there's that same 20. They have to be making these at a rate of 20 a day. So that was just a faster way to do the same thing.